Algebra 2, Unit 2.24. This is going to be our last video of the unit. So here we're going to talk about arithmetic with functions, or function arithmetic. We'll get to that in a second, but first I want to do a few more questions involving the binomial theorem. So just to refresh our memory, always a good idea to try and recall the theorems from memory. So right now, just to begin, go ahead and pause the video, try writing down the binomial theorem from memory. Once you've tried it, go back in your notes and make sure that you're correct, and then we'll move on. Alright, I hope that went well. Let's go ahead and just remind ourselves the binomial theorem states that if you have a binomial, we'll call it a plus b, to the nth power, then you can expand it, and when you expand it, it will look like this. And so I'm going to write it in both forms. First, I'm just going to write it with the one we started with. So I'll have n choose 0, a to the n, b to the 0, plus n choose 1, a to the n minus 1, b to the 1. Moving forward, skip all the way to the end, n choose n, a to the 0, and b to the n. And what does that look like using summation notation? Well, that's taking the sum from k equals 0 until k equals n of n choose k, a to the n minus k, b to the k. And notice, in case this is still confusing for you, that what this does is it says, okay, we're going to, for every k value, we're going to evaluate this expression and add it to all the ones before it. So we start with 0. If you plug in 0, you get the first term. And then the summation tells you, okay, move k to 1, evaluate it again, and add it to what you got when you had k equals 0. And so if you plug in k equals 0, you get the first term, k equals 1, you'll get the second term, go all the way until k equals n. If you plug in k equals n, you get the last term. Okay, so you can go ahead and confirm that for yourself if you need to, but now let's go ahead and try a few. So first things first, go ahead and try all of these on your own. Expand the following using the binomial theorem. Explain what is meant by the following value, and I'll put that up there in just 1 second. And then create a triangle where all the side lengths are greater than 100. Okay, so go ahead and try these all on your own. Work through them. Take your time. Use your notes if need be. Make sure that you include questions where you have them, and we'll talk briefly about them in a second. Alright, so looking first at 2 minus y to the 5th. So first I'm going to write out my binomial expansion, and I can do this from memory because I've memorized it, because I've written it down so many times. But to help yourself out, you may just want to remind yourself what you're doing. So you're going to be taking the sum from k equals 0 all the way until k equals n, which in this case is 5. And you're going to be taking the sum of 5 choose k, and the a value here is 2, times 2 to the n minus k, and I should write that as 5 minus k, times b, in this case b is negative y to the k. And so now I can just go through and write out all the values. So I start when k is 0. I'm going to have 5 choose 0, 2 to the 5th power. Next term is going to be 5 choose 1, 2 to the 4th, negative y to the 1st. Fast forward all the way. Now you would actually want to write these all out. And once you get to the end, you're going to have 5 choose 5, 2 to the 0, which is of course 1, and I'll squeeze that in, negative y to the 5th. Okay? And then you want to simplify using either Pascal's triangle or the method we have for computing the n choose k, or in this case 5 choose whatever it is. And so you can go through, and 5 choose 0 is 1, 2 to the 5th is 32, 5 choose 1 is 5, 2 to the 4th is 16, so we have 5 times 16. And before computing that, you might also want to note that this is going to be a negative y to the first. So instead of having positive, it's actually going to change to negative. So I want to make sure that I make that correction there. It's going to be negative 5 times 16. And so, of course, 5 times 10 is going to be 50. And 5 times 6 is going to be 30. So I'm going to have negative 80y. And I can fast forward all the way. Of course, you want to do the whole thing to the last term. 5 choose 5 is 1. 2 to the 0 is 1. So 1 times 1 is 1. And then we have negative y to the 5th. So again, here, any negative number to an odd power is going to be negative. So I want to make sure I cancel out that positive and put a negative y to the 5th power. Okay, you'd want to go ahead and do the same here. Only difference is that now our a value is 3x. So just to give you an idea, let's look at the first term here. It would be 6 choose 0. And then I have my a term, which is 3x to the 6th power times 1 to the 0th power. So what is this? Well, 6 choose 0 is 1. Now 3x to the 6th, that's 3 to the 6th times x to the 6th. Now what is 3 to the 6th? You're going to need to use your calculator for that. So you'll have 3 to the 6th power, if I could write correctly, that'd be helpful. 3 to the 6th power times x to the 6th power, and that would be your first term. And then you can go ahead and write out all the rest of them. For number 2 here, remember this is 5 choose 2. So that would be finding the number of ways that you can pick 2 things from a group of 5. Okay, and so if you were to compute this, it would be 5 factorial divided by 2 factorial times 5 minus 2 factorial. And you can put that in your calculator. And if you didn't have a calculator, you can write it out. So 5 factorial is 5 times 4 times 3 times 2 times 1. And then down here I'll have 2 times 1 times, and this here is 3 factorial, right? So then I'll have times 3 times 2 times 1. And so let's go ahead and cancel out. So 1's will cancel, 2's will cancel, 3's will cancel. 2 goes into 4 twice. So all I am left with is 5 times 2 divided by 1, which is 10. So that's the number of ways that you can choose 2 things from a group of 5. Lastly, we want to create a right triangle where all the side lengths are greater than 100. So remember, we've proven that if you choose 2 integers, m and n, where m is greater than n, which is greater than 0, that then we have a right triangle, and the side lengths are m squared plus n squared, m squared minus n squared, and twice mn. So the question now becomes, how can you make sure that each side length is greater than 100? And so the best way to do that is to try some values out. You know that each one needs to be less than 100, and think about it. If m squared minus n squared is, greater than 100. If m squared minus n squared is greater than 100, well, certainly m squared plus n squared will be greater than 100. What about twice mn? Well, you can play around with it. Go ahead and try a few values out if you haven't already. See if they work. What I might want to consider is, okay, I want to make this here has to be greater than 100. So let me choose 2 values that will for sure make it greater than 100. So to make this greater than 100, I could try some different things out. I could potentially do 13 squared minus, and 5 squared. 13 squared is 169. 5 squared is 25. So 169 minus 25 is going to be 144. And then twice mn will be 2 times 13 times 5. And 2 times 13 is 26, and 20 times 5 is 100, and 6 times 5 is 30, so this will be 130. And then m squared plus n squared, well, that's just going to be 13 squared plus 5 squared, and that's going to be 169 plus 25, so 169 plus 5 is going to be 174, plus 20 is 194. And so those would be the three lengths of a right triangle, and all of the side lengths are greater than 100. All right, function arithmetic. So basically what this is saying is, hey, you can add numbers, you can add variables. Well, you can also add functions, because functions are just numbers and variables. So just to give you a really brief idea, imagine you had some function f of x and a function g of x. Well, you could add those two together. Okay? You could add those two together. What would you do? Well, you'd take whatever f of x is, and you'd add it to whatever g of x is, collect the like terms, and boom, it's your new function. So here we have a situation where we have f of x and g of x, and we want to write a new function, h of x, which is kind of a combination. So it's 2 times f of x minus g of x. So we want to write this in standard form, which is, of course, not factored form. We want to multiply it all out. And so we can multiply it all out. We can then perform the operations here to get h of x. So first things first, we want to make sure we have this in standard form. So go ahead and multiply out f of x. All right, so there we have f of x. We've just multiplied it out. And now we can actually evaluate what h of x is. So h of x is going to be 2 times f of x. Well, what's f of x? It's x cubed minus x squared minus 2x. And then we're going to subtract from that g of x. And what's g of x? Well, it is 2x plus 3. And so the real key thing to remember here is that we're subtracting all of g of x, so it's everything that g of x has to offer needs to be subtracted. So we're going to have to distribute that through. And we're going to have to multiply 2 times all of f of x. And once we do that, we can reevaluate what h of x is. So this will be 2 times x cubed minus 2x squared minus 4x minus 2x minus 3. And I can just collect my like terms. I'll have 2x cubed. I have a negative 2x squared. Then negative 4x minus 2x is going to be negative 6x minus 3. And that's h of x. All right? Okay, great. Last one I want you to try on your own. So go ahead and read through the question, give it a try, think about it for at least 2 minutes, maybe come up with an example, and then we'll talk. All right, the function f of x is a quadratic function, and the function g of x is a quartic function. The function h is defined as h of x is equal to f of x times g of x. What is the degree of h? So what we're trying to figure out is obviously what the degree of h is. And what is h? Well, it's f times g. What do you know about f? Well, f is a quadratic function. So let's just give ourselves an example. Think of f. F could be, what could f of x be? Well, it's quadratic, so it's got some leading term, x squared. And what is g? Well, g is a quartic function, so g of x could be something with a leading term of x to the fourth. And what's the degree of h? Well, the degree of h is the largest exponent, right? The largest exponent that I get in h. So where is the largest exponent going to come? Well, think about when I multiply f of x times g of x, the largest exponent is going to come from those two largest exponents multiplied together. So h of x has got to have a degree of 6, right? Because I'm going to have x squared, and I might have, some other things. I might have, plus x plus 2. And what am I multiplying it by? So if that was f, I'm going to then multiply it by g, and g is a quartic function, so it's x to the fourth, and maybe I have something else, plus x plus 1 or something like that. When I multiply these two together, the largest exponent, or the degree, is going to come from that first multiplication, x squared times x to the fourth, which is x to the sixth. So no matter what the other stuff that's going on here with f and g, when I multiply them together, the degree is going to come from those two largest exponents, and so the degree of h is going to be 6. So the important lesson to take away from this is that when I multiply two functions together, the degree of the new function is simply going to be the degree of the first function plus the degree of the second function, right? So if I have a degree 2 multiplied by a degree 4, it's going to be degree 6. And that is true for anything. Okay, so we'll try a couple of problems on the next page, and then I'll see you tomorrow in class. Here we go. What I really want to see is I want you to try these on your own. So I want you to split your paper in half where you're doing this, down the middle, and I want you to do all your first attempts on the left side, and then once you watch and we go over a couple of them, retry them over on the right side. Okay? I'm not going to discuss them all, so I need to see at least that you tried them all on the left side first. All right, so first thing we note is that we want to put these in standard form, and so I'm going to need to have g of x in standard form, so that's going to be important. So what is g of x? Well, it's x minus 3 cubed. Great opportunity to use the binomial theorem. So g of x is going to be 3 choose 0, which is 1, x to the third, plus 3 choose 1, which is 3, x squared, times negative 3 to the first, plus 3 choose 2, which is 3, x times negative 3 squared, and finally plus 3 choose 3, which is 1, negative 3 cubed. And if I then simplify this out, I have x cubed minus 9x squared minus, plus, because 3 squared is 9, so it'll be 9 times 3, which is 27x, and then 3 cubed, negative 3 cubed is going to be negative, so it will be negative 27. Okay, so that's my function g, and then I can go ahead and take f of x and subtract it, so I'm just going to have whatever f is minus all of g of x. Be careful to distribute the negative there. X times f of x, notice I'm just taking, what this will look like is x times, and then it's 3x squared plus 2, so we just need to distribute that in. It's a plus there. 2f of x plus g of x, so here I'm going to have to multiply f of x by 2 and then add it to g of x. And then let's talk about the last thing here. So I have 3 functions. They all have the same degree. Well, what is the degree of p of x if it's f times g times h? So imagine that f, g, and h are all x to the n. That's the biggest exponent, and of course I could have some other things going on with it. So let's just say that here we have f, and it's x to the n plus, and then I have some other things, but they all have degree less than n, so they're all exponent smaller than. Then I have g, and g's biggest term is also some x to the n, and then I have some other stuff there. And then h of x, its biggest exponent is also n, it's a degree n, and then I've got some other stuff over here. And where am I going to get the degree of p from? Well, it's going to be the largest exponent in p, and p, of course, is f times g times h. And so where is the biggest exponent going to come from? Well, it's going to come from multiplying the first term in each, so it'll be x to the 3n. Think about it. When I multiply x to the n times x to the n, I add the exponents, so I'll have n plus n, which is 2n. Then I'll multiply that by another x to the n, so I have 2n plus another n, which is going to be 3n. And then I'll have some other stuff, but all of that's going to be smaller, so the degree of p is going to be 3n. You could try this out. Imagine that n were 3, so your biggest exponent was 3, and remember we talked about the when you multiply polynomials, the new degree is just the biggest degrees of each, or the degree of each, added together. And so there I would have 3 plus 3 plus 3, or 9, in other words, 3 times whatever the degree is.